In this video we have the integral of natural log of x squared plus x. Now there is a formula for the natural log for the integral of the natural log of x, and that's given by x, ln of x, minus x, and then plus the constant of integration. So you have something in this form, you can give the evaluation as this. Now in some cases you can write it in this form using a u substitution. Then this would just be a u here, this would be a u here, and a u here, and so on. So for this one here, we're going to use the property of log. So I'm going to factor this expression here, x squared plus x, as x times x plus 1. And then there's a property of logs that tells you if you have the log, in this case it's the natural log, of a product, you can break it down into the sum of the logs. So I'm going to rewrite this then as the integral. This then would be replaced simply by the log of x and the natural log of x plus 1. And that's going to be the integral of that sum. So I'll just rewrite this as two logs and say this one then could be the integral of the first log, then would be, or the first integral would be at natural log of x dx, and then it would be plus the natural log integral of the natural log of x plus 1 dx. So for this one, I can use the formula over here on the left up here. This would just be x natural log of x minus x, and of course we have the constant of integration. We'll do that at the end. And now for this one here, notice if I let u equal to x plus 1, then du would equal to 1 dx or dx. So this would just be, replace the x plus 1 by u, and of course the dx would be the du, and we use the same formula over here, except instead of x it's the u. So if I do that, then this would just be plus, and it's the product of u and natural log of u, but in this case u is x plus 1. So I would just write it this way. This would be x plus 1, and then it's natural log of x plus 1. And then it's going to be a minus u, but again in this one u is x plus 1, and then it's plus the constant of integration. But again, I'm not finished, so I'm going to wait on that, show you something here. So in this case, I'm going to leave this as x ln of x minus x, and here we'll go ahead and multiply this out. So this will be a plus x. So I'm multiplying, distributing here x plus 1 multiplied by ln of x plus 1, so it'll be x ln of x plus 1, and multiplying the 1 here would just give me ln of x plus 1. And then this one here, then this will be minus x, so this would be a minus x minus 1. But see, the minus 1 is a constant, so at the end I put the constant of integration. So this minus 1, I'm going to incorporate it with the c. That's normally what you do. That's why sometimes you work out a problem and there's supposed to be like a plus 2 or a plus 5 or something, and you don't see it in the answer. It's because they put it with the constant of integration. So this negative 1, this constant, is included here. Now let's simplify this a little bit more then. So let's look at these right here. This one here and this one here. I got an x ln of x plus x ln of x plus 1. So I'm going to factor an x from those two. So there's the x. And then that leaves me with ln of x plus ln of x plus 1. You can express, just like I did in the beginning, where I took this product, ln of x times x plus 1, expressed it as a sum, and go the other way. So this, factor the x here and the x here, I got ln of x and ln of x plus 1. I put those together then, it's a sum, so I can go backwards and express that as a product. So this would be x times x plus 1, so that would just be x squared plus x. And then what's left over here? We have here the ln of x plus 1, so this will be plus, and this is ln of x plus 1. And then I got the minus x, and then I have then the constant of integration. So final answer then is x times ln of x squared plus x plus ln of x plus 1 minus x plus the constant of integration. Thanks for watching. We'll see you next time.